Hello everyone, thank you for listening to my report. I'm excited to share our research on urban morphology's impact on thermal environments, focusing on high-density areas in Harbin, China. Harbin, a cold city in Heilongjiang Province, has a population of about 9.4 million across over 53,000 square kilometers. Our key findings include significant variations in land surface temperature between day and night. The differential impact of urban block classification and the cooling effect of green spaces in high-density areas. With global warming and extreme weather becoming more frequent, urban populations face increased risks from the urban heat island effect and rising temperatures. Research shows that urban heat island effects are often studied in warmer climates, leaving a gap in knowledge for cold regions like Harbin, where rapid urbanization has intensified warming. A large number of studies show that rational planning of urban spatial form can effectively reduce the urban heat island effect and its negative impacts. Urban blocks are ideal units for urban planners to develop strategies for improving the thermal environment. Thus, studying land surface temperature and urban morphology at the block level in dense urban areas is essential. To fill the gaps, we selected Harbin, a densely populated cold city in China, as our focus. We first analyzed land surface temperature patterns using ecostress data. Then, we classified urban blocks into 9 categories based on building density and height, extracting green space characteristics from each category. Finally, we calculated a distribution index to assess how these block categories influence land surface temperature, using Pearson correlation analysis and stepwise regression to identify key factors. Our study focused on the warmer months, collecting 2 high-quality data scenes at 10:17 on August 10, 2022, and 19:07 on July 30, 2023, both with a spatial resolution of 70 meters. Meteorological data came from the Harbin National Base Meteorological Station, while urban block data was sourced from OpenStreetMap and Baidu Map, which provided information on building locations, boundaries, and heights. As in previous studies, we define our block categories based on density and height, resulting in 9 distinct classifications, and the calculation formula of distribution index is as follows. Here is the description and calculation method of urban green space morphological characteristics. Results show that during the day, high temperatures are influenced by urban features like buildings, water bodies, and green spaces under strong solar radiation. At night, warmer areas are primarily found near the Songhua River and its surrounding mid- and high-rise buildings. Our analysis revealed that the average surface temperature of different block types varies with the time of day. In the daytime, High-density residential blocks showed the higher temperatures, while lower-density residential blocks had the lower. This indicates that building density significantly impacts daytime temperatures. At night, HRHD still had the highest average temperature, while LRLD remained the coolest. The distribution index confirmed that HRHD blocks, which represent about 16% of the total, had the highest values of both day and night. Pearson analysis showed that all urban green space indices significantly correlate with urban land surface temperature. Total class area, percentage of landscape shape index, and aggregation index are negatively correlated, while patch density is positively correlated. Stepwise regression revealed that green space characteristics explain 36.8% of daytime and 23.4% of nighttime temperature variations. These findings suggest that strategies to mitigate urban heat islands should consider both daytime and nighttime temperatures. Expanding green space area can effectively lower daytime temperatures, while increasing the discrete degree of green space patches helps reduce nighttime temperatures. Unlike many previous studies, we analyzed irregular city blocks, which are basic units of urban morphology. This approach highlights the potential importance of green space indicators in mitigating heat island effects in high-density areas. Our results offer new perspective on managing urban thermal environments at the block level. However, our analysis is limited by the lack of continuous land surface temperature data, as we only used 2 eco-stress observations. The availability of longer eco-stress records in the future will help to more accurately reveal the diurnal variability of the land surface temperature at finer scales. Additionally, we did not propose a combined strategy for managing temperatures during both day and night. Incorporating a broader range of urban design factors and examine how these factors affect temperatures at different times could enhance our understanding and strategies. Thank you for your attention and welcome any questions or discussions.